Hello, hello everybody. Hey Matt, hey, we
Hey.
got Joe here and we got Pat here. Welcome everybody to Devs in the Shed. So just to recap what Devs in the Shed is for those that may have been, their first attendance here. Matt and I both work for AWS. I'm a solution architect. Matt is one of our principal TAMs. We both work in Melbourne, Australia, and we like to get hands-on. We like to build a lot of things, explore a lot of the new features that come out with AWS. But we're also really interested in IoT and building some things. We spend a lot of time playing with Raspberry Pis and seeing what's capable in that area, and building some electronics as well. And this week we've got Pat, who's an associate solution architect at AWS, and Joe as well, to come on, and I'll let those two introduce themselves, because they're going to do a little bit of a talk and a demonstration of something that they've been working on with their Raspberry Pis and integrating that into AWS. So maybe I'll start with you, Pat, and we'll give us a bit of an intro of yourself and what you've been doing and where you came from.
Sure, yeah. So a bit of intro about me. Now I'm at AWS, an associate cloud architect there. But my journey in the cloud really started about a year ago. I actually worked with Joe in a team in NAB, and that's where I got exposure to a whole bunch of AWS services. More specifically, I actually got the opportunity to work on an IoT project, which sparked my interest in a lot of machine learning, what you can do with camera work, what you can do with SageMaker. And since then, it's really just evolved. I'm continuing to learn what is possible with IoT, and hopefully today we'll go through some of the concepts that I've learned across the year till today.
So yeah, how about you, Joe? Like, I know that you also worked at NAB, because we actually happened to work together in the past.
Yeah. So just as Pat said, we both started at NAB, even you as well, Paul. And ever since then, I think that a big part of what I do at work is exploring the AWS cloud. I do a lot of web development, a lot of software engineering, and so it's a bit different for Pat and I think, coming from a very software, web dev focus into IoT and like getting your hands dirty. It's very, very different. But I think that over the past couple of days, exploring Greengrass, IoT Core, a bunch of different services that you have no idea what those services even mean before you even start. It's been really interesting, and I think that we've learned a lot from it. But yeah, so hopefully today we'll be able to showcase what we've learned and what we've created.
I know originally when we were sort of just floating the idea of you two both coming onto the show, you both spent some time building up a community event that you were going to go ahead and share with some of the local universities. So something that was like above and beyond your day-to-day work. So this is a keen interest of yours, and you think that it'd be good to be able to spread this information through the unis. Tell us about what you've been doing with that.
Yeah, so I think with us, with me and Joe, what we kind of felt was at university, you learn a lot of technology, you learn a lot of theory, but I think for us, for our personal experience, was going through university, we didn't really get that exposure to the AWS platform, but more specifically, we didn't get that exposure to a lot of Raspberry Pis, how we can make this IoT, and what even is the concept of IoT. We knew about it loosely, but we didn't know how to put it into a machine. So about mid last year, Joe and myself, we decided, hey, there's not enough exposure showing students how to do these things in real life. So why don't we start engaging our community, which is students of doesn't even have to be tech degree, just an interest in making machines do stuff over the internet, which has really led us to a whole bunch of series. Like, we've done a lot of workshops around software mainly, but I think in the next month or two, one of the workshops that we really wanted to go into was setting up an IoT project. So setting up some sort of Raspberry Pi where the students go in, they do some sort of calculation at the edge, and then they feed it into a React website. It's a simple project, but just that whole concept of being able to say, hey, my device over there is streaming information, the creative ideas that can come from that are free flowing. And what we really want to do is we just want to hand it to students to say it's not impossible. You just need the building blocks, and then students by their own nature will explode with that simple idea.
Yeah, I think that's really important, and it'd be interesting to know, is anybody in the audience today a student at the moment? So you don't necessarily need to be a university student, but are you enduring along some secondary study at the moment? Yeah, student for life. I think that's pretty much spot on, Matt. We're always trying to learn something new. But I, you know, when I do talk to people, and especially students or somebody coming into the tech field, and they tend to not understand or appreciate like how broad the technology is, like not just technology, but programming and interactions between that, and what needs to be programmed on edge devices. And one of the most simplest, you know, pieces that I talk to people about is, you know, almost every elevator in any modern building that you're going to go into has some sort of smarts behind it. So there's a lot of programming and work that goes into, you know, is the elevator at maximum weight? Should it stop for the next floor? Where is it in regards to going up or down? What is the most efficient mechanism the elevator should move? And, you know, there's programming and there's IoT and there's edge computing that happens all over the place. But connecting those two things together to sitting in front of your computer and writing some code, and how that ends up being on a device or what that can do for real life, can sometimes be a bit of a jump there. So yeah, it's a really interesting space. Before we kick off into the demo, I just thought I'd touch base with Matt, because he did talk to me about an announcement that he saw this week around Amplifier. I know he's really passionate about Amplifier, and I thought he might want to talk quickly about that.
Yeah, it's literally my favorite service. So we can quickly have a quick chat about that. I might actually get a screen share up. I'll just walk everyone through it very quickly. Whilst I'm doing that though, Paul, has your background changed a little bit? I see something from National Geographic, and I see something from one of my favorite cartoon series.
Oh yeah, I've as we set up the series, I thought you know, I'm making more use of my shed. I want to make it a little more personalized. So yes, I've got my my Rick and Morty poster up there. I think I you know, if you think like, yeah, sure, the show's funny, but what I like about Rick is he can just do it all, and I think that's what we should think about when we're builders and we've got like a platform like AWS at our hands. When customers come to us or the business comes to us and says, I'd like to do this, is this possible? I think pretty much the response that we give back almost always is yes, that is absolutely possible. It might be like expensive, it might take a long time, but certainly that is possible. And I think that correlates really well with Rick. You know, he can do anything that he wants to do. So I like him in that regards. Plus, it's a funny show as well.
And he builds his way out of every problem, right?
Yeah, and so like I've got here the National Geographic rock tumbler, and that's probably a bit of a bigger story. And at some point in the show, I think I'd like to like bring that in. But you know, my kids were watching a YouTube channel about a rock tumbler, and a rock tumbler is effectively a little barrel that you just turn slowly, and you put some grit, so sort of like sand, gritty sand, and then you put some gemstones in there, and it just turns for days and days and days. And slowly but surely, it'll take those gemstones that have rough and sharp edges and smooth them off and make it really smooth and make a really nice polished gemstone. So that is just a replacement one that I bought. And I've got like a bunch of different services hanging on a website that I built with that you know, at some point in time, it'd probably be interesting to like hook some of that up into AWS services so that, you know, we could have some control of that. I do currently have that live streaming at the moment. It's turned off right now. I don't have any gemstones in it. But yeah, it's an interesting little subject there.
Nice. No, that's very cool. So I've got my screen share up. So I'll just bring it across for everyone. Here we go. So the first thing that came in Amplify this week is that the CLI now supports environment variables and secrets for Lambda functions. So this is really, really cool. One of the hardest things in software development, I think, Paul, you can attest to this, is like, how do you manage your secrets, you know, effectively? How do we make sure that we don't accidentally push things to GitHub? Where do we place them? And how does the app read those when deployed? So using secrets manager and environment variables within Lambda is going to make a bit of a difference, I think, in terms of making Amplify easier from a security perspective. But The other feature that I haven't played with yet, and I just saw it came out as well, is that we've got extended CI/CD capabilities with an amplifier. So one of the things that we do have customers mention is, they do want more control over the resource generation, especially within dev, UAT, and prod implementations where they've got multiple branches, one for each with Amplify, and they want things to automatically build when a change is detected in the Amplify folder and not necessarily override what's been done in the current config. So this is probably something that I'm going to experiment with in the coming weeks, but I think it's just going to give people a bit more stability moving their stuff to prod. So that's a really good thing too. I guess any comments from your side on that one, Paul, in particular?
I think, as you mentioned, and it's probably because in the last week I had a couple of different side communities that I'm involved with and I support. There's always questions about how do I go ahead and manage those credentials, whether they be database credentials, Amazon keys if you don't have capability to apply like an instance role to that, keys to any sort of third-party service, because like I know in the past that I've seen organizations that I've worked at have someone that has accidentally committed, access keys or something like that to GitHub. And, it's definitely not something that you want to happen. So having some sort of like rigor around managing your secrets and environment variables is really important. Amplify does such a great job of abstracting away so many like difficult and complex services, in bringing in, Secrets Manager to start beginning to expose some of the developers that are taking advantage of what Amplify brings to them and the speed of the development it brings to them, but also ensuring that they're operating in a secure manner and protecting those, usernames, passwords, keys, whatever they need to be protecting. So yeah, I think that's a really good feature to see Amplify continuing to not just enable like fast and rapid development, but to ensure that it's secure and following best practices.
Yeah, and I think the reason why I like Amplify so much is you can just focus on building customer experience, right? So you can do that across like your native mobile app. You can use Flutter. You can use like React and React Native if you're writing a web app. So it just makes the whole process easier to access cloud functionality quickly. And then the other thing is, at the end of the day, a lot of what it generates in the AWS land and the console side is all through CloudFormation. So you can kind of customize to your heart's content once you've learnt what Amplify is doing and the basics of AWS. Then you can take that step to deepen into each particular service and further customize things. So it kind of gives you that flexibility as well, which I like. And Cognito especially, right? I talk to so many customers that want authentication done easy. And sometimes they just use Amplify solely for the authentication aspect, which is pretty cool as well. I know that we should probably have a look at what Patrick and Joseph have done. I was going to say, as you guys were talking, like I think we met originally back in one of your workshops, actually. So I know you guys have been so involved with the community across Melbourne. It's been really fun to kind of accidentally bump into you guys during workshops and meet that way. And it's exciting to see that you guys are continuing that relationship that you've got with students. So yeah, let's dive into what you have today.
Cool. Should we start? Yeah. So I guess we'll talk a bit about kind of how this workshop came about first. So again, we run like a little student club that kind of, it's essentially teaching university students about AWS, something that I think doesn't really exist right now, or there's not enough of it. And so one of the workshops, as Pat mentioned, was we were going to run a IoT workshop in the next couple of weeks. And so I guess we're going to teach very basics of IoT, different services and how to use them. So if you head back to the screen sharing page, Matt, I'll show you.
Should be up now.
Yep. So I'll start with let's pull up the Raspberry Pi cam as well, if that's possible. So we'll do a quick little demo and then we can talk about what's exactly happening.
Anyone use Greengrass, by the way? I have yet to fully touch it properly. Just let us know in the chat.
Yeah, I think it's a relatively, V2 came out maybe a few months ago only. So it's pretty new. At least V2 is very, very new, and V2 is quite different from the first version. But right now you can see in the remote cam, we've got a Raspberry Pi set up and it's connected to the Raspberry Pi camera. And so we bought this off Amazon. pretty easy. We put that together, and if I point the camera, let's say I point it to the front here, and let's try and get an image. And how I've set it up on Greengrass is that every 10 seconds, it's going to take a photo. It's going to run an object detection model to try and detect all of the objects within that image, and then it's going to spit that back to the React app. And so you can see here, it detected a TV monitor, which I assume is probably potentially that, or potentially the screen. And what's really, really cool is it also, if I run this command really quickly.
Now, I mean, humans are pretty good at recognizing objects, right? So what kind of use cases would you say this could be handy for?
Yeah, I think not only object classification, but also like image classification. Like our initial idea was to create this biometric authentication system where, you know, you'd have like a camera, right? And then that camera would then detect if you were, you know, the authorized user. And then it's like Face ID essentially. And then through that, you can then personalize certain things. We were even thinking of hooking up to our coffee machine and, you know, creating coffee based on your personal configuration, right?
Yeah. I think what we're demonstrating here is, as you said, Matt, I see a TV, I display a TV, but I think the bigger picture of what we're probably doing here is we're feeding into machine learning capabilities at the edge. So you can think of this being the first step to a series of machine learning capabilities. Like the other day when we were thinking of an idea, we thought we've got machine learning at the edge. We can do something like motion detection. What if we came up with a random idea where we just have a camera? Now it's a bit of a wacky idea, but we had a camera pointed at you just operating in the house. And let's say you're a vivid coffee drinker. You like to drink coffee, but it takes roughly 10 to 15 minutes for the coffee machine to get ready. Imagine if we had a machine learning camera that would go and imagine if we had a machine learning camera that could learn your habits, that could learn whenever you feel like a coffee. And then based on that imagery, based on those habits, it could then pre-warm the machine. That's just one spitball idea, but you can connect this image detection, object detection to a whole bunch of other ML capabilities that can then spin off into a bigger solution than just detecting that's a TV, but it's actually acting on those detections.
I think I really like that idea, right? So you could be sitting there, and sometimes like this happens. Like you start getting a bit grumpy. You don't connect the dots, but then you get that notification that says, you know, based on your previous habits, we know that at this time you're probably going to want a coffee. So you know we've warmed it up and it's all ready for you. So that's a really interesting idea. Joe, I think you're using the phone there as a camera to show us sorry, Pat, you're showing us the camera. Do you want to just zoom in really close and show us that specific camera and talk about how that plugs into the Raspberry Pi itself? Because I have one and mine was like really, really cheap, but I'd love to hear about the one that you've got there.
So I think the camera we've got here it's a Raspberry Pi module. It comes it comes as an added accessory to the Raspberry Pi. So we have a Raspberry Pi here sitting in its case. And then as you can see there's a bunch of pins, or there's a slot. And this slot is specifically designed to be capable with this camera. Now this camera is a no IR, correct?
I believe so, yeah.
Yes, so it's a no IR. It's a camera that just comes with a lot of cameras come with infrared capabilities. This one, in more specific, this is towards the other end, so it doesn't come with it. But you can really customize. The good thing about Raspberry Pi is they have a whole bunch of modules, whether it's cameras that are capable of LiDAR, I'm sure there's out there, or even high res, low res, color, no color.
Just to add on to that. We bought like a hand gesture module that's specifically designed for Arduinos, and we were trying to connect that up to the Raspberry Pi, using the input output pins, and as software people, it was very, very different. We were soldering, we were doing a bunch of different things that we wouldn't usually do, and then we connected it, and then we were like, how do we actually use the hand gesture module? And it wasn't a very simple process. The process to actually do that it's a very low level at that point. So in order to actually use that module, it takes a lot more effort than, say, something like this, where in order to use this camera, it's as simple as installing a library from pip. You do camera.takePhoto, and that's it. Your photo is taken. So
I think even enabling the camera on the actual Raspberry Pi, it's like there's one command that you hit enter, you navigate through a menu, and you just say camera enabled, and that's it, right?
It's very, very straightforward. Yeah. And compared to the other modules that we got, like we ended up just focusing on the camera, but the other modules were a lot tougher to integrate.
But it's also important to remember that. So like the other day, we were looking at other modules offered by Arduino. The difference between this module and an Arduino module might be just that with this module, it comes built for this camera. So all we had to do was just slot it in.
Exactly.
But then on the software side, where we're actually telling it what to do, all we have to do was, I'm pretty sure it was pi.enable camera. It comes with the built SDK, whereas with Arduino, you need to do
it's very low level,
a bit more, but it's still possible. It just requires, we were fortunate in that we knew someone who knows electronics, but it's still very much possible. So anything out there that's a module, regardless of what platform it is.
And how much was that little camera?
This was, I think it was around exactly maybe 30 to 40, around that range. So it's below 50, I think, or maybe around there.
So because I think the one I've got is a lower megapixel range, and I think mine was like $10 or something.
This is like it doesn't really say here.
Yeah, they start around 10, and then depending on features like no IR or night vision or high quality Raspberry Pi camera, they go up to about $100.
Yeah, we've got just a quick question here from E7 Twitch, and he asks, what's the difference between Arduino and a Raspberry Pi? Who wants to take that? Matt, do you want to answer that? Or Joe? Pat?
Matt.
Do you want to take Matt? Probably.
Yeah, I can take it. But basically, Raspberry Pi is a board with a processor on it, and you're able to have an operating system run on top, and you're able to do all the kind of normal functions that you have with a computer. Whereas my interpretation of Arduino is it's got a chipset on it, but it's very much based on constructions and instructions, and it's very low spec compared to a Pi, right? Like you couldn't run a desktop OS on it. You can only run a very particular OS with a series of instructions on it. There we go. Simon's probably articulated it a lot better than me. Arduino is a microcontroller.
I've got one right here. I'll just try and find my Arduino, and I'll show you.
I haven't actually ever set mine up. Mine's still in the box. So I haven't played too much with the Arduinos. I'm more of a Raspberry Pi guy because I quite like to have like a full desktop environment on it.
It looks like I've got one of the hats for an Arduino, but it kind of looks like this. So the Arduino kind of looks like a Raspberry Pi. Actually, this is a hat for it, but it kind of looks exactly the same. But to like what Matt was saying, like the Raspberry Pi has like an ARM processor that enables you to run like an actual operating system, so you can run Linux on that, and that's how you're able to like have a screen and connect it all up. Whereas an Arduino is it's a microcontroller. So you write some sort of like code that is really low level and is telling precisely what the device should do. So it's like you're getting like a little chip and programming those controls on that chip rather than building a complete computer as an operating system. So the Arduino can still go ahead and interact with specific devices and take inputs and outputs, but it's not going to go and run an operating system. But you might use an Arduino in tangent with the Raspberry Pi. So the Raspberry Pi is running the compute and running some of those resources, and probably what we'll see a little bit more of today with what we're using with IoT Core, and the Arduino collecting that data or some sort of data or information from some sort of instrument, feeding that to the Raspberry Pi, and the Raspberry Pi is doing the compute behind there to go ahead and process that data.
Show the diagram.
So, yeah.
Okay.
So.
Cool.
So I
Alright,
might get
let's
your
go ahead
screen
and
share
have a look
back up, actually.
some diagrams.
Yeah, should we dive into?
Yeah,
kind of
let's have a look at the diagram you've got.
Yeah, so this is something we put together, but essentially what's happening in the background is you have your Raspberry Pi here. And before we go into that, let's talk about Greengrass first and what Greengrass really is. So Greengrass not only runs in the cloud, but there's something called the Greengrass core software, or I believe it's something similar. And you can actually install that as a software in your Raspberry Pi itself. And what it does, it kind of acts like a runtime. So you install that onto your Raspberry Pi, and you can see here I have a component here called the DLR object detection component. And what's really cool is that how Greengrass works is you have kind of two entities. You have cores and you have components. And so what a core is I can install a core software onto multiple devices, right? And each one of those devices with that software is considered a core. So in this situation, I have a Raspberry Pi, and that's my one core essentially. And components, on the other hand, are kind of like software that you can run on these cores. So I can run, a software for publishing to a MQTT or another software for subscribing. And so you can essentially deploy multiple components to a single core or a single device in this case. So right now, the way that we've set it up is we've got a Raspberry Pi here. It's running the Greengrass core software, and it also has the object detection component. And what's really, really cool here is that because the cloud is essentially controlling the runtime, the DLR object detection component was actually a public component that Amazon provided online. So it's like a little marketplace, essentially, like a little list of managed components that AWS already offers. And you can simply click on that component, deploy, and it jumps onto your Pi. That's it. So it's very, very easy. In fact, that model didn't require any coding, which is actually quite interesting.
I might just add to that. So for software people, when I was working with Greengrass v2, how I thought of a component was a bit like a Docker image. So for those who don't know what Docker is just this abstraction kind of thing where you build an image, and then regardless of what type of system you run it on, Docker can run it there. Now with a Docker image, you can run multiple processes that all do their own independent stuff. With components, that's how they kind of interact with a Greengrass core. Greengrass core is the software or the OS you install so that it can really benefit, so that it can sync up with the Greengrass cloud.
Yes.
And then with components, you specify two things. You specify a recipe and an artifact. A recipe is simply the instructions, kind of like your Docker file, the instructions to run the component. And then your artifact can be anything from code that you want to run or a machine learning model. Those two together, once you deploy that component to the core, then it just runs like a Docker container. It just runs its code, which in our case, we're publishing detection models to the cloud. And what Joe was saying is that even if you don't know how to do machine learning, or even if you don't know how to do Greengrass version 2, what he was just saying is that AWS offer public components. So they offer pre-made components for popular things like machine learning, which is what we're doing on our device here. Yeah.
And just to add on how you were saying, you have this like Greengrass core software that is your runtime or your OS essentially. By doing that, right, if you have, say, 50 IoT devices, right, and you connect that all to the Greengrass cloud, and they're all running this Greengrass core runtime, right? If you want to deploy a piece of software and you want that to trickle down or to cascade to all those 50 IoT devices, right, it's as simple as uploading it to the AWS Greengrass cloud, and that'll then deploy that component or whatever code changes that you want to make to every single IoT device that has that Greengrass core software and matches up with they call it thing groups.
I think it would be good to show the console even, just a few of the key
for sure.
components.
Yeah, probably would we go through that. And so, I mean, you raise a really good topic for anybody that is not aware of what IoT means. It's like Internet of Things. And so they are things, like these are things that we are connected to. And Greengrass is that system that helps manage your things. And when you think about like those things that are going to be managed, and they're not necessarily like computers that are connected all of the time. They can be in a completely disconnected state, and Greengrass helps manage the ability to have a disconnected state, and when you do connect, to be able to push out some of those changes.
Yeah, 100%. So as you can see in the console itself, as Paul was mentioning, you have your core device here, you have your components, you have your deployments. So if you look at our core devices, this is the Raspberry Pi that we've set up. And if you take a look at thing groups, as Paul was mentioning again, right now we've only got one group, and in that group itself, it contains this one core device called Greengrass. And obviously I can add more core devices and whatnot. But if you take a look at the components, you can see that I have 3 components right now. I have the CLI, and the Greengrass CLI allows me to test my components locally. I can use this CLI to do a range of different things as well. I have a test component that is just a very simple one that I've been using. And the DLR object detection component, this is the one that AWS has provided as a public component. And if you take a look here, as Pat was mentioning about how a component consists of recipes and an artifact, you can see if you click on view recipe.
Yeah, I might just talk through. So referring to before, a component is just something we deploy to the machine.
Yeah.
It has a recipe, which it's kind of funny because a recipe is almost a cookbook to making food. In this case, it's a cookbook to build my whatever I'm running. So in this case, you can see that a recipe, it really comes with a lot of options, but the key ones to remember is the component configuration. So in your component configuration, you can introduce the type of access you want this. In AWS, you want to make sure that you're fine graining your access. So in this case, we're limiting that access to only publishing on this certain topic. So we can't interfere with other processes. Then you can introduce, now these are parameters that are specific to the machine learning inference code itself. You can customize that to introduce, maybe you want your own machine learning model. All you have to do is change a few parameters without even looking at the inference code. You can just use what they've given you in this public recipe. And then of course the manifest. The manifest is really where the grunt or where the core program comes to life. The manifest tells us stuff about how we should run this code once this deployment. So you can see in this certain case, you don't have to understand what the script's doing, but it's just essentially saying, once I deploy this code, I want you to inference and then give me detections on this topic every 10 seconds. But you can customize that. You can run your own code. We did a Hello World yesterday just to try it out. That was our own custom one. And then of course we specify our artifact. In this case, we're using the
object detection model,
the public one offered by AWS. But like another example we were trying out yesterday was deploying our own custom model. You can definitely just replace that there. So there's a lot of control, even platform specific. So you can see that this one's for AMD 64, whereas others can be for Pis or for Ubuntu or whatever operating system. So it is quite powerful. And then you can obviously, once you're happy, you can create different versions of that component. Once you're happy, you can then deploy that component to either a group or a core, a group just being a series of core objects. In this case, we've played around with many, but the active one here is just the one that contains this Pi.
Yeah, let me just show that deployment process really quickly. If we click on that, if you look, this is the list of public components that AWS offers. So you can see you have one for Firebase, Firehose, you have one for token exchange, you have a bunch of different ones. But let's say we want to deploy a DLR object detection. And as Pat mentioned, you click deploy, and let's say you select your current deployment group. And I just want to show one feature that I think is really, really cool. If I click next here. Okay, so I guess with these public components, right, you have a very standard baseline component. And let's say you want to edit a little parameter. Let's say you want to change the model that you want to deploy. As Pat mentioned, there's this massive recipe. So how do I go about changing that recipe in order to customize this public component? You can actually click on this selected components, click configure component. And if you scroll down a little bit, you can see here that I can have a configuration update. So right now you can see that my last deployment, the only difference that I made to this public component was actually activate the camera and make the inference interval, which means how often am I making predictions to 10 seconds. But if I wanted to, I can make this 100 seconds potentially, or I can add a bunch of different other parameters that I can then redeploy and customize that, that public component to something else, right? So it's very flexible in that scenario. Or you could, you know, if you really wanted to, you can just copy the recipes, copy everything over to a new component and deploy it as a separate component.
Exactly. Yeah. It's a runtime updating on the fly.
Yeah. Super, super interesting.
I wonder if anyone had any questions about Greengrass v2. What's your thoughts on them? What's your thoughts? Maybe Paul, have you played with v2 before?
I've set up some small little demos similar to what you have done at the moment. And so probably what's interesting and people might wonder about is how do you ensure like secure communication between what's on the device and what's in the cloud? What is doing that?
If you want to talk.
So prior to this, actually, prior to doing the Greengrass implementation, we looked at IoT call by itself. So how do we communicate from an IoT device to IoT call using MQTT by itself? And that process, and it's weird that Greengrass doesn't really, well, I don't think we really went through the certificates and everything, but when I did it manually, we had to do that. And that involved, what we ended up doing was if I look at, if I show you the things here. So the very first Pi that I set up was this one. And if you look at certificates, you can see I have one certificate here that is automatically generated when you create your thing. And you then essentially, I essentially transfer that certificate to my Raspberry Pi. And when I am making that MQTT call or that publish call to the cloud, right, I have to specify the certificate, and the certificate needs to be attached to a policy. If I look in security here, a policy right here that allows that Raspberry Pi to publish and subscribe to the IoT service. So there's a range of different protocols here that I think ensure secure communication. I think that's the benefit of using something like IoT call.
So the security is there is handled by mutual TLS, which ensures that nobody else can intercept that message that's moving in and out of the cloud. Exactly. Developer Steve got a question here. Does Greengrass do over-the-air updates? Now, I presume that what Steve is asking here is, if we have a different version of that specific component, can I go ahead and just push that out from the console, and will that deploy to those devices? And the answer to that is yes, it can do that. And so like they can be in a disconnected state, and obviously if they're in a disconnected state, so if that that specific image capture device was on a remote farm location and only had internet 3 months of the year, well, it would work in an offline state, and obviously the update wouldn't get pushed to that. But if there was an update available and they were connected to the internet, and so it didn't engage that connection to Greengrass, then yes, you'll be able to get that connection.
Something to add about that?
Yeah, we definitely, in terms of updating, versions, about 2 days ago, we were experimenting with components for the first time. So at least on my account, I have about 16 different versions of Hello World. So it's really good if you kind of want to keep updating and testing and then rehearsing it. Components is the way to go. You can adjust it as far as you want. You can adjust minor parameters, or you can change the whole recipe, and you can just create versions and then continually push them. And then Greengrass Core is really the beauty in that it handles the whole TLS, it handles the whole getting the code, getting the models, and then making sure that the machine is really working. And if it's not working, it also provides logs on the device itself. We definitely use that a lot. Yeah.
It'd be interesting, Joe, to go back to that high-level overview and just show us how those pieces can fit together, and then maybe give us a look at the Python code that you had to go and write to show how this is capturing the images and passing that up.
Yeah, for sure. So I guess we've kind of covered what the Raspberry Pi does and the core software and the component. We've also covered kind of what Greengrass is and how that deployment process works. I guess the final part of this diagram here is actually talking to the IoT core, as well as then feeding that information to the React website. So the component itself, every single time it takes a photo, it then publishes to a specific topic that you specify to IoT core. And then from the React website, we then subscribe to that topic, and we then listen to topic, and then we then display that information. So for the Greengrass version, there actually is on the component side. Oh, I think we need to. Yeah, hold this.
That's okay.
Yeah. From the Raspberry Pi point of view, the component itself, again, we're using a public component, so there is no code there. But let's just say for this version, which was the first version that we created without Greengrass, this is using recognition. We actually did have a Python script, and I can kind of show how you would go about, using the camera to take photos, sending it to a recognition model, and then sending that to MQTT. If you were to do that manually, if I show you the code here, this is kind of what we've come up with. But you can see here that we essentially set up our MQTT client, and we put in the endpoint, which is specified in the IoT. I think if you look at the console,
So in the console, you define an MQTT topic?
Well, the endpoint right here is specified. The MQTT topic doesn't really matter. You can publish to whatever topic that you want, as long as the policy does allow for it. You can see here that my topic is ML/predictions. But once I set up the endpoint, I set up the client, the MQTT client here. I also put in my credentials, which are, again, the certificates that we were talking about earlier, as well as some other settings. I can then connect to that client. I set up my recognition client here as well. And then in terms of actually running it every few seconds to send that information to the cloud, we take a photo. And this is what we mean about how simple it is to use the Raspberry Pi camera. You simply import that library from Pi Camera. You click camera.capture. You then send it to recognition, which is a service to essentially an object detection service. And then we then publish that to the ML predictions topic pool. And then we can actually go to the test section in the IoT. And here we can then subscribe to the topic and actually see those predictions coming in real time. But that's kind of how you do it, if you didn't have a public component doing everything for you.
And maybe for the audience, and even Matt can jump in here as well, maybe just to talk a little bit about recognition, because there's probably a few people that haven't used the service or haven't heard of it. So maybe Pat, you give us an overview of recognition, because I know you've worked with it quite a bit and used it in one or two different workshops before.
Yeah, I'll give a brief overview, and then Matt, you can add on.
Yeah, I'll jump in that slide. Yeah.
But yeah, recognition is really anything involving machine learning imagery, whether you want to detect specific objects or even if you want to detect if a famous person's face is detected in an image. Recognition abstracts for those who don't want to deal with but maybe don't understand the machine learning elements at the lowest level. It's a service that you can communicate via API and still leverage on all those services, whether it's object detection, image classification, image sensory. It's really a service that you can use where you don't have to spin up a model, train a model, but rather you use the inbuilt AWS models
Yeah.
to do those inferences. Yeah.
Yeah, and it's really cool. Like it looks at video, if I remember, as well as images. So you can kind of feed it anything. That includes like maybe even a real-time stream from a camera from video. I think I've seen someone give an example of that. You can look at like things like our motion. So one of the cool things that we did in Amplify Days last year, which is like the mini conference that we have for amplifiers, we had an app where all the panelists were using it, and we looked at like their sentiment in real time as to how they were reacting to the speaker. So you can use it for those types of things like facial recognition. You've got object detection, like recognizing animals, objects. I've seen people use an amplifier as well to look at grapes on a field. So they're looking at like vines, and they're basically like they're identifying that there's grapes appearing on the plants. They're looking at the color on top of that as well of the grape to determine like when might be the best time to pick certain patches that they've got. So I've seen some really cool work there. Trying to think of other use cases that I've seen. You can read text as well, I think, too. Yeah, go ahead, Paul.
There's also like content moderation. So like so many of like, I know myself, I've built apps where I enable people to upload photos and images or videos. I'm sort of into like a bit older cars, and people do take advantage of services where you can upload whatever you want, and they're displaying, you know, images that might not be like appropriate or suitable for the website that you're building. So content moderation is something that's also really really thoroughly used with the recognition service. So to make sure that whatever you're displaying to your public audience, you know, you can set a threshold to determine what you want to display and what you might just you know, flag as requiring human intervention or moderation, and another area that you say like we're definitely going to exclude those images and we're not going to bring those up as well. And you know, thinking about that is, you know, as a developer, we have to think responsibly. We have to think about our customers and protecting our customers and their websites. And services like recognition, exposing these type of like complicated services as an API that I can say, here's an image, give me back some information about that image, and I'll make my own determination whether I show it or not. That's, you know, miles different from a few years ago where you said, okay, I really have no idea how to determine whether this image is, you know, of a cup or of an elephant. So, you know, it's really like enable developers to take advantage of machine learning in a really consumable and easy way.
Yeah, you can also, like, really interestingly, I think as well, is you can also look at like the amount of people that might be coming through camera as well. So you can kind of do guesstimates when you're running events and things, like with the amount of people that are attending or in a certain section as well. So that's also really handy from an events aspect. And I was talking to a client about it recently.
Wow.
Yeah, no, recognition is, it's an easy plug and play machine learning that we can go to. And it's definitely when we were trying out this model, before our second version, we definitely use recognition. But I think it might be worth showing, because obviously what we've done is, well, the first version was very manual in terms of we subscribing to that MQTT. Do you want to show IoT rules? At least just the options, because I think this is a more digestible way of dealing with your MQTT topics. And it comes with a whole bunch of ranges. Like, you don't have to write the code and the certificates. You can just preemptively build up your actions, and then your actions can then do the relevant. I'll show you. It probably makes more sense if you see it. But an IoT rule is simply, I think, probably generalizing it, but it's a listener to me on the cloud. It's listening for that specific topic that you've designed, and then based on that topic, which in the black box here, you can see here that you can create your query to make sure that you're pulling from that specific topic. So you can even change your query to only pull relevant data, and then based on that data, you can do a whole bunch of actions. So up the top here, you can see we can, if we wanted to store that in DynamoDB, if we wanted to push that to an SNS message. So you can think of an application with our Raspberry Pi let's say we built some sort of detection for, let's say intrusion, right? We put it into a secure location, and if it detects a person, we want immediate SNS to make us aware. All you have to do is deploy that component and then ingest that via a rule that sends me an SNS message. Or maybe I want to store it for data analytics, or even push it into a cluster. So I think this is a more easier way to digest it, but you can definitely, like in our React website here from the diagram, we definitely created a listener. But with IoT rules, you can make it a bit more automated, a bit less manual. And then instead of your React website listening to the device itself, it's only dealing with the Dynamo table or the Kafka cluster or whatever data store you have.
Yeah, just to add on to that.
So it's a nice like low code way to put filters on your topics and enable like specific triggers to different services that you might be wanting to do.
Exactly.
Like for context, like rather than doing this section, essentially, you don't need to subscribe to that topic using your React website and create that code itself. Like we were even thinking of using Kinesis Firehose to put it on Kinesis and then get React to integrate with Kinesis, and that way we have
a real-time dashboard that's updating, something like Kinesis into Elasticsearch or something real-time, and then just seeing those detections change on your screen. So there's really a lot like these. This is just, you can really go wild with any of these. And then of course at the bottom, you can really go wild with just HTTPS endpoints. From there, you can introduce your own custom ideas.
So you've got hooks into some existing application you've already got installed. I'm interested on how you connected the current solution, React. Like, can you show us the React code that's connected to the current?
Yeah. So if you take a look at, let's take a look at this code right here. So it was actually very, very simple. Again, pretty similar to the code on the Raspberry Pi itself. You set up your MQTT client using all of your parameters and whatnot. And then we simply then connect it there. And essentially it's listening to a specific topic called ML DLR object detection. And every single time a message comes in, it'll then set a state in the React app, and then it'll then display that as such. So it's a pretty simple listening, and we were just simply using the AWS IoT device SDK, which allows us to talk to that MQTT client and subscribe to that topic. So again, this is one way of doing it. We could have potentially, rather than publishing it directly, we could then latch onto Kinesis or latch onto Dynamo and then ingest it from there. But this is one way of doing it as well.
Simon just asked if you could make the font a little bit bigger. So maybe just enlarge it. There's probably something there that Matt's like itching to talk about, and that is you've got the keys sitting in the code there, and like that's front end code. So obviously this works in a demonstration point of view, but this is where something like Cognito would come in, amplify, and its tight integration with the Cognito. Matt, how would you go ahead and wrap this up to be able to use temporary access key and ID with authentication?
Yeah, so this is definitely something that you could use Amplify for, right? Like you could have the end user log into the application. You can use the amplify add auth command in the CLI to build that backend infrastructure, and then you just load the amplify auth library in. Behind the scenes, it's set up like a Cognito environment. From the front end point of view in React, when the user actually logs into the console, that will all be driven by Cognito. Cognito is really cool because you've got like your user pools, and you can have like RBAC off on like a database that you've got. But you can also have like temporary IAM roles issued out as well, which will allow them to allow users to interact with AWS services as well. So that way you can kind of obfuscate the need to go down the key management process, right, and have AWS keys in your code in particular. I guess the other thing is, if you did want to go down the route of not having Cognito, that new feature in Amplify could have helped as well, where you've got like the ability to use, our password stores secrets manager, for example, to manage certain secrets that you might want to keep hidden. I'd still always use Cognito though, those things myself, but like I think of other times where I've got like keys for mapping software. I've got keys for other APIs that I'm calling. That's probably when I rely on Secrets Manager to combine that stuff in.
Yeah, for sure.
Just a question for the audience. Is anybody in the audience using Cognito at the moment, or has anyone had any experience with Cognito or Amplify, or is that an interesting topic that we might like look at in the future? So as we wait for the feedback with that, Joe and Pat, you can carry on. So I mean, look, it really looks like it's pretty easy there. Like you've got a React website, subscribe to an MQTT topic,
Exactly.
and you just listen to the events that are coming through. And
that's it, exactly. Yeah, and we just update the state as that comes in, and you have essentially a live dashboard to some degree. Yeah.
Do you want to like give us another demo of that now that we all sort of know how the solution fits together? Put a couple of objects in front and see whether it picks them up and see how accurate it is.
Yeah,
let's put a cup. Hopefully it detects that. And then I'll go in front of it as well.
Might need to be that's upside down, I think.
Oh, okay. Spin it around and see if it gets me.
Oh, takes the person. So what we can actually do now is we can actually copy the bounded image that it actually spits out. Let me just pass it here. But if you look at, you can see here that it's a little bit wobbly and it's not necessarily the right angle, but you can see that it's got a box around the person that is detected. But yeah, it's really, really cool how it works. We can maybe... Do
you have like a banana or something, or like...
I'll go
maybe... What about what's on your jumper there, Joe?
Oh, it's a cactus.
Will it detect cactus?
We could. We'll try the banana. Yeah, the banana's coming.
We can try. We're not sure what it's.
I'm not sure if this is the right way around too. I'm not gonna lie. Maybe we should.
Let's see if it detects.
Yeah, we'll just
hold still.
So right now it's set to make a prediction every 10 seconds, and obviously we could adjust that.
Person.
Yeah, it's probably.
I think it must have been adjusted.
Yeah,
holding it.
Let's copy that down. Oh no, it is. I think it's just a bit wobbly.
It detected me.
It's a little wobbly. Let's try that again, and I'll try and be more stable. Oh, it's like shaking.
Doctor's hands.
So this is using recognition at the moment. I'm guessing you're just picking the top item off the list, because it probably comes back with a list of different objects that are being detected.
It should come back with everything.
So this is using it's detecting me.
Oh, maybe it's not that great of the model.
This isn't using recognition. This is using probably the same model.
Yeah.
But like in this case, let's say we wanted an application that was built to detect bananas, for example. We could build that model just by giving it bananas and a whole bunch of stuff. And then instead of deploying the model they have on this, which is probably not built for these types of bananas, then our model would be able to be built for those.
Okay.
So there's customizability in machine learning if it's not quite. Like yesterday, we were playing with SageMaker Neo. So Neo is another service that's built to put models onto these edge devices. We put in about 10 photos of Joe because we were trying out that face auth example. And then I ran an inference and then it worked. It detected that it was Joe between the two classes of me and Joe.
Yeah.
I think just Joe and Pat, do you have the public reference to that specific recipe? Because Chief Sung asked about what it was. Yep. So he asked, what are you using for the image recognition? So that was a specific recipe that you guys were using rather than just passing it directly to recognition.
For this specific Pi right now, what it's currently running, it's actually not using recognition. It's using a public component called the DLR object detection.
Image classification.
This one's object detection.
Oh, it is?
Okay. Yeah, it's object detection. Yeah. So you can see here, if you go to the Greengrass console, it's one of the public components. It's using the YOLO through Darknet VOC model, and some more details are here. So you can take a look at how exactly this model works here. But again, it's a very plug and play, very, very modular.
Yeah. If I remember, YOLO, YOLO's really, it stands for you only look once, if I remember correctly. And YOLO, the idea is it takes that screenshot or that snapshot, and then it tries to put bounding boxes around things that it recognizes as well as a label.
Exactly.
Just like we do, we're pretty much on time. But what about if you were to go quickly in the console, navigate to recognition, and upload that banana photo? Let's just see what recognition would do for us.
All right,
just to show the audience the difference. So
Yeah,
Amazon Recognition, you can interact with it as an API, but if you just want to explore it and play around with it, you can upload images directly in the console.
So let's try label detection. And we can then
get banana off the internet or something.
Or we'll use the same image, I assume.
Oh, yeah.
Yeah, it's really fun to play with this because you can play with all the features on the console, and it's you can learn a lot from it. So let's try that. Yeah, so you can see recognition does detect it as a banana plant.
This is kind of what I expected a little bit more to come back with. So this is a really, this is a strong model of 99.2% that's a banana. So, exactly what we expect to happen. So that this sort of demonstrates the power of like the recognition service. And what Joe is showing now is like the payload that you would expect to come back if you were interacting with an API. So, there's a lot of information that you can pull out around what has come back and what is detected. So awesome.
Cool.
Well, guys, like it was a really like interesting session. We'd love to have you back another time as you begin to flesh this out. And once we do, you do formalize the event and have, an open invite for anyone that happens to be in Melbourne at that point in time, we'll go ahead and we'll share that as well. So we'll share that on our Devs in the Shed website and on episodes when that comes up. But yeah, excellent session. It's really, really interesting stuff and really fun to think about what you can do, like, I guess, easily with edge devices and Greengrass, and how it ties, your separated device to something within AWS Cloud to do proper computing.
Yeah, no, thanks for having us on board, Paul, especially one of the earlier episodes. We've achieved this in 2 days, so we're keen to flesh out, we really want to go wacky with this idea.
We have a wild list of different ideas.
So hopefully the event will be something a bit out there, a bit creative. And definitely, we want to stretch our limits on what we can do, and then obviously give that back to the community so that they can then further it themselves.
Yeah, awesome.
Yeah, very nice. Thanks for coming along, both.
Thank you. Thanks, guys.
All right. Well, thanks everybody, and thanks everybody that came along and watched today. Really appreciate all the feedback that we get and all the interactions. It's a great time, and special thanks to Joe and Pat for coming along today and showing off this little workshop they've been putting through. And Matt and I will see you next week at the same time, same sheds.
Cool. Perfect to see you, everyone. And I think it's containers next week, so it'll be fun. So think containers, but think IoT. IoT.
Thank you, everybody.
Awesome. Thanks, everyone.
Bye.
All right, bye.
Thanks, guys.
See you guys.